Good morning, everyone. We will start within a minute. Good morning, everyone. We will begin this session by introducing our resource person, Mr. Vasant Kumar V. Vasant Kumar V graduated as Electronics and Communication Engineering from Anna University, Chennai, currently designated as an Assistant Manager in VI Solutions, Bangalore. He has 8 years experience on NI technology. He is handling the major responsibility of
with the support of the ICT ATAL Academy, we are able to digitally transform the teaching and learning process in the country to a greater scale.
sorry for the interruption. He has handled handling the responsibility of supporting various industries in implementing several turnkey systems and system integration projects using NI technology. He is also handling the major responsibility of improving the quality of engineering and science education and eradicating the impoverished methods of education and inculcating the interest of for LabVIEW. Vasant, as the first and only certified professional instructor for Indra, that is India, Russia, Armenia, and Africa, National Instruments and CLD certified, and has traveled far and wide throughout India and has delivered thought-provoking lectures and kindled people interest towards LabVIEW, and also visited more than 150 Indian engineering institutions for various domains on LabVIEW basics and data acquisition. He also had conducted many faculty development workshops on various trending technologies, including digital image processing, data acquisition, and control, etc. He has delivered 200 plus lectures on experiential engineering education on varied technology topics. His key interest areas include embedded system, automation, digital image processing, sensor, data acquisition and signal conditioning, wireless sensor networks, etc. Uh, with this short introduction, I heartily welcome you, sir. And I will hand over this session to uh, Vasant sir. Vasant sir.
Yes, sir. Thank you so much for your introduction. I'll quickly share my screen so that you people let me know that whether you can see it.
Yes, sir. Please, sir.
So I'll open my PPT. So is it visible to you all?
Yes, sir.
Hope it is visible, right?
Sir, kindly. Yes, sir.
It's visible. Okay. Thank you so much. One clarification I need before starting. so that I can just conduct this session in a better way. So do we have possibility of hands-on for the participants?
Sir, participants are, I think, they have already been informed about the software, and we have already shared the links to download the software, I guess.
Okay. So that this session can be a demonstration plus hands-on, right?
Yes,
For
sir.
the benefits. Because I recommend hands-on session. The reason is this toolkit which we are going to demonstrate, right? And this is not going to be one session or 1 hour session. It's going to be like 5 days of session. So until unless they practice these many huge amount of content, they will not be able to reproduce the codings or like reproduce the technology. That is the reason I just insist. So today is fine because it's going to be basics, but from tomorrow onwards or from today lunch onwards, if you want to take hands-on, please let us know. So we'll see what kind of arrangements we can make for you people, right? So this tool has to be, done with hands-on. That's the reason I'm just telling you. All right. And first of all, I just want to thank your management to just give a wonderful opportunity for me to just interact with you people, because this is a honor to me. And this is really happy to share my knowledge. See, I have some knowledge in industries. I've been doing this for many years now. So I'm glad that now I'm able to share this knowledge to people. Until unless I share something, I don't think so. I'm just doing something, justice to my profession, right? So on this regard, I'll just quickly take you people through the agenda. And in case if anybody have queries, please stop me in between. All right. Please let me know that, if you're not following, or if you want, clarity, further clarity, or if you want, a repetition of some topic which I'm just doing, please let me know. All right. And you are welcome to just ask any queries related to your applications which you are working on, or your projects or your research, whatever it is, please let me know. So if I can help you, I'll just do it. If not, I'll just route it to the right person who can help you. All right. So today's agenda, I'll just classify it into 3 sections so that you people know at what place we are standing at any point of time. So section 1, I'm just going to take you people through NI technology and LabVIEW. So I don't know how many participants in this session has idea about what is NI technology and LabVIEW. So National Instruments, NI basically stands for National Instruments. Okay. So National Instrument is a leading automation company which provides solution, engineering solutions, especially for automation, controls, monitoring, logging of data, reproduction of data, right? Controlled loop systems. All these applications, they try to provide, a lot of solution through hardware plus software. All right. So regarding that hardware, yes, coming from tomorrow, we are going to jump directly into the hardware part, where we'll be just demonstrating a lot of devices, a lot of features of devices, a lot of different types of sensors, different types of signals, how to interface them, how to control them, how to make a closed loop system, how to make it to be a standalone application, because we also have embedded devices to show a demonstration to you people. So that we'll also show you how to design an embedded standalone application. Yes, for moving further, we'll also be demonstrating you people how to do a mobile communication also, like, how to control these applications through mobile, which is going to comprises to be an IoT application. Because when you say that I'm going to push the data into the cloud, based on that data, I'm going to control some unit or some sensors, then obviously it is going to be, paving a path to your IoT application. So that is the plan we have for this entire week. That is why I'm trying to tell you this. Until unless you know how this is going to be turning out, I don't know how serious you're going to take it. So that's the reason I want you people to just know what are the things you are going to cover. So if you see even your agenda of this entire week agenda, which was shared by the management, college management, you will come to know that, there are a lot of, in-depth concepts of, industrial applications are going to be there. All right. And the software which will be used by National Instrument to control all their devices is going to be a software named LabVIEW. So which you see here in the screen, that is the toolkit which is going to be, programming all your devices, which we are going to see in this entire week, right? So today is going to be a demonstration and, a complete illustration of how LabVIEW is being used in industries, how it is being, providing solution for engineers in various domains and various applications. I'm going to show you all. All right. And section 2 is going to be LabVIEW's environment and the data types. So how to program the different data types in LabVIEW, how to quickly design some application to understand the environment, what are the things needed, that will be shown to you. And section 3 is going to be, decision making structures and iterative structures. What I mean by that is, say in LabVIEW, if you want to do an application where you want to repeatedly do a task, right? So that is basically called as iterative structures. Okay, so if you want the application flow to be like looped again and again, based on some condition, it has to loop it yourself. So those kind of applications can be done using iterative structures. And decision making is, as the name suggests, so based on some conditions, if the decision has to be done, should I go on with this particular code or this particular code or this response or that response, everything can be decided using a decision making structures. So overall, this is going to be the agenda for today. So the vision of today will be, you should be knowing what is LabVIEW and how NI technology is using LabVIEW and its hardwares in industry. That is number one. Number two is you should be completely comfortable with the environment of LabVIEW. All right. So you should be knowing simple basic application to design. This basics is needed for the upcoming sessions. All right. So tomorrow it's going to be something like, hardware interface will come up. You'll be writing a program to know how to acquire from a sensor, how to acquire from multiple samples from a sensor, how to control analog signal, how to control a digital signal, how to generate a pulse width modulation application, so that you can control speed of a motor. So all these things you'll be learning in the upcoming sessions in this 5 days. All right. So this is going to be the basics of that. So unless you know this, how to do it, you'll not be able to, execute that application which is going to come in the upcoming sessions. All right. So quickly jumping into the section 1. So I'm going to quickly take you people to the National Instruments powerful graphical platform. Name is LabVIEW. All right. So quickly talking about National Instrument. If you are not aware of National Instrument, once again, I'm going to quickly introduce you to the National Instrument company. So hope you people know, for example, I can just take an example to you people is like a Philips. Hear about Philips, there's a company called Philips. Most of the people would have heard about this company, Philips. What they basically give you is they give you, lights, they give you, geysers, they basically give you trimmers, hair straighteners, toasters, right? Even iron box. So these are the items they give. I can classify them that like Philips is one such company which provides, electronic gadgets that will be useful in your day-to-day application, in your household application. I could say that way, right? So more similar to that, your National Instrument is one similar company like your Philips, but only difference is National Instrument provide various different types of hardware. These gadgets what National Instrument provide will not be used in home appliances, right? So that's why you don't see any trimmers or any toasters or any geysers in the name of National Instruments. Rather, National Instruments provide hardwares that will be useful in industries. All right. So when I talk about industry, when you see an industry, there will be a lot of machineries will be there. These machineries needs controlling. So National Instruments provide devices that can control, automate, actuate your industrial hardwares, industrial machineries. It can be of different types of machineries, from high end to the low end industry. I mean, industrial machineries, it can control everything. All right. So that's what National Instrument does. And they are very powerful that, I don't know how many of you have heard about it, very powerful that even other automation companies use National Instrument products for, validation. So what does mean by validation is, let me say I design an application, I expect some output to come out of that application. All right. For a provided input, I need an expected output, right? That's what everyone does. So whether my expected output is really, a trustworthy, whether it is going to be a reliable code or whether it's going to be a reliable result. So how would I know? I have to verify it and validate it. So to do this, what they do is they use NI Instruments, National Instruments application. So generally, National Instruments is basically setting a huge standard for this application. That's what we are going to look today. So LabVIEW basically stands for, LabVIEW is the software which is be useful for programming this National Instrument hardware. So LabVIEW basically stands for Laboratory Virtual Instrumentation Engineering Workbench. I repeat, LabVIEW stands for Laboratory Virtual Instrumentation Engineering Workbench. That name itself talks about many things, right? So this is a tool or a workbench. What is a workbench? Workbench is nothing but a platform. It is an engineering platform which allows you to design virtual instrumentation for all your laboratory purpose. When I talk about laboratory, it's not only your experiments in academic level. So when you talk about research, or when you talk about hands-on applications, or when you talk about trial and error applications in industries, yes, LabVIEW is going to be the perfect tool for that. See, if you see here, you can see a computer which is running a program. this program is a graphical program. That is a main aim. So LabVIEW is a graphical programming. Whatever you see here is a graphical LabVIEW program which is running on your computer. And you can see there is a control unit. This is a control unit from National Instrument usually. So there are different types of control unit. The way the interface, from the form factor, how many inputs it has, how many outputs it has, what is the range, what is the resolution, what is the sampling rate. There are a lot of information which varies, and there are a lot of devices from National Instrument. One such example I'm trying to show you, it will interface with your computer. So your LabVIEW program will be controlling your control units. All right, the control units, whatever you see here. And these control units will be connected to the machineries through some inputs, output pinouts, and it will be controlling the entire devices. Right? And you can also not only parallelly control it, you can also deploy your code. Can you see on the next picture here on the right side top? You can write a program in LabVIEW. Whatever you see as a LabVIEW program, a simple example program, and I'm just deploy it into a particular PCB also, right? So you can put it on a PCI card or PXI card, and you can deploy the application so that it can be executing on an embedded platform, right? So when I talk about embedded platform, one advantage of LabVIEW compared to other toolkits is one particular software without any changes. One particular software can support your desktop platform. What is a desktop platform is? It can be any OS, like, it can be Windows. Windows has multiple versions, Windows XP, Windows 7, Windows 8, 8.1, 10. All right. LabVIEW supports all the Windows version. Same LabVIEW. You don't have to even worry about anything, or you don't have any different versions of LabVIEW so that you can install on a particular OS. So same version of LabVIEW is very compatible for all the OS. The same version of LabVIEW can be used for real-time application. When I talk about real-time application, it is nothing but RTOS, real-time operating system. You can deploy your LabVIEW application into a real-time operating system without any changes. It can also support your microprocessor, microcontroller units. So you can deploy the same logic into a microprocessor, microcontroller. You can also deploy your LabVIEW code into a FPGA. Many people don't know this. See, when I talk about FPGA, I don't know how many people from this background will understand about that. FPGA, when I talk about it, is a high-end embedded system where usually we do HDL programming, hardware description language programming. Usually worldwide, people consider only 2 HDLs. So till now, when I talk about programming FPGA, everyone talk about only Verilog and VHDL. All right, people will talk only about Verilog and VHDL. That is a very well-known HDL. But actually speaking, there is 3 software which can do the HDL. One is Verilog, one is VHDL, and third is LabVIEW basically. So you can write the same program in LabVIEW and you can deploy into FPGA where it can generate the bit file. You can deploy the bit file into your Xilinx chips or any other chips, whatever you wish to use. You understanding? National Instruments are defining what are the chips you can use for this purpose. Unlike other Verilog and VHDL where you can deploy into all the FPGAs, National Instrument defines what are the FPGAs that can be programmed using LabVIEW. That constraint you have. But still, you can program to most of the FPGAs, which is programmable through Verilog and VHDL. Am I clear? Yes. So there are a lot of applications you have. The reason why LabVIEW would be used in industries is, when I talk about that, first of all, I want to tell you people like how many industries use LabVIEW. Okay. So NI technology and LabVIEW. If I talk about that, the N number of companies around, right? So I will just put a lot of whatever I come to know and whatever I can put into one single slide. I'm just showing you all. All right. So if you notice this list of companies that are using NI technology, most of these companies are like manufacturing sectors. So when I talk about manufacturing sectors, they want to use LabVIEW and NI technology. Number one for its efficiency, reliability, and number two is like rapid prototyping. Well, I'll tell you what is rapid prototyping because you should know why people use National Instruments, right? So if you see what are the names, you will be commonly knowing. If you don't know, I'll explain them. So AMD is one such company which provides your graphic cards, your DDR RAMs, all the chips related to your computer, inbuilt computer. It will be provided by your AMD company. All right. So Boeing is one such company which designs flights. NASA is one such company which provides spacecraft, missile launchers. That's what they provide. There are like Ford, Ferrari, Nissan, Honda, Toyota. So these are like automotive company where they design cars or like some of the automotive applications. They also use LabVIEW for their CAN, LIN, flux array protocols. Usually, if you see these people design some units, ECU, electronic control units. So these have to be programmed with LabVIEW usually. All right. And apart from that, if you see, you have Motorola, you have Philips, some of the known companies I'm talking about, Nokia, IBM, Kodak. Kodak is image processing based company. Then Cisco is networking company, and HP, GE, General Electronics, Xerox. Xerox is one such company which provides a big photocopy machines. You know that, right? So that one. So apart from that, also there is companies like Honeywell, Rockwell, Yokogawa. These are some such big companies. They're already into automation. They have their own, even ABB. So these companies write their own automation applications, right? But still, why they use any technologies to verify and validate their results in PLC and SCADA. So Honeywell or Rockwell or ABB or Yokogawa, these companies basically write their automation applications in PLC to control it with, to control it, they use SCADA. All right. But still they use NA technology to verify and validate their application. So they use NA technology and LabVIEW software to verify it. All right. So these many companies are using, there should be a reason why these many companies are using NA technology, right? So I'll just quickly tell you about that. Before that, I just want to make a highlight of one such company which is in recent time using LabVIEW. So hope you people would have heard about a company named SpaceX, right? So if you have heard about SpaceX, you should also be knowing about a gentleman named Elon Musk, right? If you are famous, if you are browsing your internet and social media regularly, you would have come across this guy a lot. If not, you should check about it. If you don't know about SpaceX and Elon Musk, you should be going and checking back about him. So I'll tell you quickly about the SpaceX company. So till now, there are a lot of countries which are designing satellite communication. They are designing rocket space. They are also designing space shuttles. But most of the company, not most of the company, every single organization which is like running for the space crafters are usually private sectors. Public sectors. Okay, so ISRO is from India. Governed by Indian government. If you see other countries also, for example, if you see NASA also, NASA will be governed by US defense. So they are all happening using the public sectors. Okay, the very first company which was a privatized spacecraft designing company was SpaceX, the very first. And it is not only the first, it is the only company which is like designing spacecraft in private sector is SpaceX. An individual person running it, his name is Elon Musk. So what is the hype about the SpaceX is they're trying to design space shuttles that can usually nowadays, if you see what are the spacecraft is designed, that puts the satellite on the orbit, and it is made to crash, or it is made to fall back into the earth in such a way that it is not destroying any of the land. It will be programmed to fall in the oceans usually, right? So whereas SpaceX is the only company which is designing in a spacecraft in such a way it goes and comes back alive, so that you can reuse the spacecraft for another trip. So it's more like flights. So if you see your flights, you send from one country to another. So it takes off here, lands there, once again takes off there, lands here. All right. So, but rockets are not such way. Rockets are not meant for that particular application. You have a lot of components which will be sent to the space, but that they are not all the components are going to return back. You know that, right? You would have seen launching how it is happening. Whereas SpaceX is the first company which is designing an application in such a way, every single component are going to return back in such a way we can once again assemble them, and once again we are going to use it for the next spacecraft application, right? So when I was just going through one of their website, like understanding what are the things they use, I was like astonishingly looking into some of their websites. There I just found that they are using LabVIEW also. All right. So once I just saw that they are using what are the programming they are using, I was able to find that they are using other applications also, but together they are also using LabVIEW. So I just got curious. So I just went on and just tried to find out what they were using. And I just found this, which you are seeing. It's a screenshot I've taken. I sniped it so that I can show you that what is it happening. So I'll just quickly read it to you. The ground software team is about 9 people, right? So the ground software is nothing but, the Launchpad team is basically 9 people. We primarily code in LabVIEW. So we develop the GUIs. GUIs basically stands for graphical user interface. We develop the GUIs used in mission and launch control for engineers and operations to monitor vehicle telemetry and command the rocket spacecraft and support pad equipments. So what they're trying to say is, so in the ground stuff, like in the launch pad where the spacecraft is launched and it is going to be landing, because these people have landing feature also, right? So they are using the GUI. GUI is nothing but the graphical user interface. What I mean by is, even in your ATM machine, if you see, there is a front end where the users are graphically interfacing with that, right? So the application looks graphically representing, where you just can see buttons, pictures of buttons in the window, and there's going to be lot of prompting windows, like asking you to type something, asking you to feed something, asking your confirmation. So that's basically a GUI window where you can interface with the application, right? So these people are also using LabVIEW for designing this kind of application, right? So obviously you'll be wondering, like, how many big shot companies are using any technology. There should be a reason. Obviously, I'll just quickly tell you why LabVIEW. What is the reason why these many companies, and even the recent companies? Just think, a company which is doing this spacecraft application, do you think that they are going to use LabVIEW, which is, or any tool, not only LabVIEW, any tool which is going to not make future? These people invest on particular tool or domain, or on engineers or some experts or some of their facilities, infrastructure, only if they know there is going to be making future, right? Because their ultimate motive is like invest on something which is going to be lasting for at least for a couple of decades, right? So if not centuries, at least for a few decades, it has to be alive. The technology, they don't want to keep on changing the technology. So that's why LabVIEW comes into picture. So I'll just quickly show a demonstration or like comparison between LabVIEW and other programming languages. So programming language, what you see now currently is a C programming. Hope you have used it before. So what is it doing? If you go through it closely, you'll see that it is doing addition of two numbers. C equal to A plus B. It means the addition of two numbers. So usually C is a textual programming language. Hope you know it, where you type your programming textually, right? So you type your programming textually. That's a textual programming language, and it executes sequentially. What is meant by sequentially is first line executes, then the second line, then 3, 4, 5, 6. It keeps on going. That's why you should put them all in the right sequence. You can't jumble them. You can't write printf at the top and the hash include at the bottom. Gets it somewhere in between. Scanner somewhere at the bottom. You will not be able to do that. All right. So they run on a perfect sequence, and you have to follow the sequence, and that is why we call it as a syntax. So you have to properly follow the syntax, how it's supposed to be programmed, right? And usually C program has two windows. One, a blue color screen where you type your program, then you compile and execute it, and you'll get a black color screen where you'll be prompted to type your inputs and the output will be visible. So this is a programming window. The blue color screen is a programming window, and the black color screen is a execution window, or in other ways, you will call it as a UI screen, user interface screen, where the application prompts you, application interfaces with the user through that window. So it prompts you to type some data, and it will do the process and will apply the result to you, right? So I'll also show you a Java program. So Java program, what is this program doing? This is also doing addition of two numbers. Now let me compare the C and Java. So how many lines of program did C use? Let me quickly count. 3, 4, 5, 6, 7, 8, 9. Nearly like 12 to 13 lines of program, your C program is using. If you see Java, it's like nearly 8 lines of program it is being using, right? So you might ask, what is the big difference? Both are same, right? What is the big difference? There is a huge difference. Let me tell you what is a huge difference, and you'll now understand why Java was dominant over C for few years. If you see like around 2005, 6, around those time, there was a lot of requirement for Java developers. Okay, they were like slightly moving from C to Java, JavaScript. Even now, JavaScript many people are using. I won't say no. I'll quickly tell you what was the reason like Java was predominantly being used over C. I'll tell you that. See, this is the addition of two numbers, basically a first and max, I can say, right? Adding two numbers and displaying the output in a variable. That is what these two are doing. A C program has taken 13 lines of program, whereas Java has taken 8 lines of program. You can ask me what's a big difference. There is a huge difference. Just think, this is a very small application. Java is like minimizing the length of the code, memory of the code, memory print of the code. All right. But when it comes to Java, it is basically using higher amount of codes. Just think, I'm designing a huge application. For example, I could say, for example, IRCTC tackle booking, right? IRCTC ticket booking, train ticket booking. Let me take that example. Or Ola app. You use Ola app to book a cab, or even that one, or even your Book My Show to book a movie, right? So if I talk about this, you have logins, Then you have to specify from which source to which destination you are traveling through train. It will populate all the list of trains. You have to select the date. Then you have to select what type of seat you want. There are different types of seats, you know it, right? And what type of criteria you prefer, like you are senior citizen or you're looking out for a takkal ticket, whatever may be it is, special consideration, you have to just make it. And after that, you have to go for you have to give your details and go for your payment. When I talk about payment, there are like n number of different ways to pay. You have UPIs, you have credit cards, you have debit cards, you have wallets. There are a lot of ways to do. And that takes you a different passage, and you have to program in such a way that it will get a message to your phone, it gets authenticated, and your amount will be deducted from your account, right? And then that particular seat will be reserved for you, and no one else can occupy that seat for the next trip, until the next trip, right? So this much amount of programming you're supposed to do. Whatever you see here in the screen is just addition of 2 numbers. Just think the amount of code this particular software will be using. It will be a huge amount of code this particular applications will be using. All right. So just think, if I was writing the same program, which I was telling you in C program, maybe it is trying to take 10,000 lines of code. But Java, let me say it is going to take only 6,000 lines of code. You can ask me what's the big difference. There's a huge difference. The time taken to develop is like nearly half the amount. The number of people I engage on this is half. Number of people I pay for wage is half. Testing is going to be quicker. Validation is going to be quicker. Response of the machine is going to be quicker. What is my response? If I request the application of C to execute something, you know it's a sequential execution, line by line execution, right? This C has to execute 10,000 lines, whereas Java has to execute only 6,000 lines, right? So that's the reason if you see in AT machine also, some machines will be pretty faster, some machines will be slower, because at the back end there are huge amount of codes running, right? So they have memory, they have to initialize the memory, they have to de-initialize the memory, everything is there, right? So that's the reason Java was predominantly used over C. See, just think from industrial point of view, manufacturing sector point of view, I have 2 teams. I am a company which is designing some application, okay? I have 2 teams. Let me say I'm designing a spacecraft only, okay? I have 2 teams to do it. I have a C team which can do the same task. I have Java team to do the same task. Whom will I prefer? I prefer Java. The reason, forget about technical aspects. I am a management guy. I don't know anything technically. I want the things to be done on time, because my customer is waiting. My testing is there. After that, I have to launch the product and it has to hit the market. Advertising is there. Marketing is there. And everything further comes. All right. So I'm a person who don't think much technically, whereas I think which is going to finish my job at the earliest. That is what I will be thinking from a management level of person. Being a management level of person. In that case, I'll know that Java has to be used, because I can know that Java can be faster. I know that it is going to be pretty faster and has more features. And I also know that I don't have to deploy many people into that, because it can reduce the workload, right, compared to C. That's the reason people started using Java widely in industries. Then I'm just quickly going to give you introduction to LabVIEW. Whatever you see as a LabVIEW window, I'll quickly tell you how this works. There are 2 windows. There is a front panel window and a block diagram window, right? The name says front panel and block diagram, right? Your front panel is a UI, more similar to your black color screen of your C program, which prompts your input and gives you the output. So it allows you, it requests you to print, type your input here, and it gives you the output here, right? So your front panel is a replication of a UI window, whereas block diagram is a replication of the program, whatever you write. Right? Block diagram is a place where your actual programming takes place. So if you see here, you can just clearly understand there's a variable X, variable Y, which is passing a data to add function, and the add function is passing a data to the output. So you can see that there is a X function, Y function. So they are giving the data 4 and 5, and added output of 9 will be displayed here. Getting it? What is the advantage here compared to C, Java? You can see that LabVIEW concentrates only on the application. Int sum equal to A plus B on Java, or C equal to A plus B in C. Your LabVIEW will be concentrating only on the application. If you see the programmer's life or engineer's life, or even student who's doing developing an application, they will be more comfortable with like this line of coding. C equal to A plus B, everyone will write it. Int sum equal to A plus B, everyone will be able to write it. But what are the other syntax lines where we'll struggle, or the lot of errors, bugs, validation, everything has to happen on this. More effort is involved on these lines of coding. The syntax, basically. All right. Not the application, because we know what to do. We know what is application. We know what is the requirement. We'll be able to do. LabVIEW concentrates only on the exact application, not on the syntax. That's why you can just check out any websites you want. Most of the graphical programming language. What is a graphical programming language? Here you draw it. You don't type data, you draw the data, you drag and drop them, connect them together, draw the application, it works. Whereas in C or Java, you write the program, you type the program. It is going to be characters oriented application. Whereas when it comes to LabVIEW, it is going to be more of graphical, where you draw them. So if you see any graphical programming language, they don't prefer using syntax. You will not have syntax. You just know what is the application. Just drag and drop them, connect them. Even, I don't know how many of you use PLCs. PLC programming, if you used, they use ladder logic, where they just simply drag and drop the items, connect them together, make a sequential execution. All right, that's why it's called as a ladder logic. Whereas LabVIEW don't even use ladder logic, it's a data flow model. I repeat, LabVIEW is a data flow model, which means that the data flow through wires. Okay, so the data flow through wires and they get executed. You're getting it? Yes. So because of this reason, this particular reason, LabVIEW is being used by n number of applications, n number of domains. All right. I'll tell you, this is also one more reason why industries use this. See, if you talk about an industry, now currently I'm doing application on image processing, let me say. After finishing the image processing, and the result of the image processing, I get as a signals, images I'm going to convert into signals. I want to apply some windowing or some DCT analysis or whatever, maybe some signal processing I want to apply for the images, right? So you should find an application that supports both signal processing and image processing, which many applications that's. For example, let me talk about, your MATLAB. MATLAB supports it. It supports both signal processing and image processing. You're understanding? Now, let me say this is a simple application. Next, I want to interface a camera. Because image processing, I just want to extend it into a video processing. So I want to connect a camera. I want to do the processing in camera. Now I have to think about a platform which will help me to do it. Right? So now let me say I have a camera, which, or like I have multiple cameras. Like I have one camera from Basler, one camera from Sony, one more camera from National Instruments. The 3 different cameras I want to parallelly acquire. I have to find out some software which will allow me to do control and grab the data from all cameras. After finishing, let me say I want to do some artificial intelligence to the application. I should find out once again one more application to do that. After that, I want to push it into cloud. The results I want to push it in the cloud, right? So to do that, once again, I have to find some application which will help me to support IoT. So there are a lot of problems will come up. We don't know in the future what are the many things going to add up. When you talk about especially research work, we don't know. You people have done research, a lot of research you people have done. We don't know what point of time what you want to add. Only if you jump in and start working on it, you'll realize, okay, maybe I should do this. This is how I'm supposed to do. Maybe I'm supposed to change this. This is how it works basically, right? So LabVIEW is one tool which supports these many applications or these many domains. You can program everything in a single application. I'll show you a demo, don't worry. I'll show you a demo, right? So if you see here, what are the major applications? You can do data acquisition and control using native NI hardware and also non-NI hardware. You can also do image processing, signal processing, camera-based applications, robotics, real-time embedded system, real-time operating system, FPGA program. I was telling you about FPGA programming, right? Yes, FPGA program can be done for high-speed data acquisition, and then biomedical application, biosignal application, bioimage application. It is possible. You can also do it for your artificial intelligence application like machine learning, deep learning, neural networks, and also pushing the data into the cloud and making your entire application to smart factory, industrial revolution 4.0, how to do it. Then going for a triple E application, electrical application, high-end application, like you want to acquire, manage voltage, amps, all these current rating, phasor measurements, how to design a smart grid, how to design a microgrid, how to distribute the data, how to design and validate electric vehicle, how to manage a battery systems. Everything is possible. Converters possible. Then you can also go for control system like PID, fuzzy system, validating, system identification, or coming back to your communication protocol. It supports Modbus, USB, all different types of communication, RS-232, RS-488. Then going for CLAN, LIN, FluxRay for automotive application. For avionics, if I talk about, the communication will not be normal serial communication. It will be RINC or AFDX or military standard 1553A or B. All right. it supports 5G. Most of the companies are doing their 5G research in LabVIEW only. All right. Cisco is tied up with LabVIEW. I was showing you Cisco right in the previous slide. Cisco is tied up with LabVIEW to do their 5G research. Apart from that, mechanical and civil people also use LabVIEW for machine condition monitoring, machine health monitoring, noise, vibration, harshness, NVDT test. Then NDT test, like non-destructive testing. A lot of applications you can do with LabVIEW. All right. So LabVIEW completely solves the engineer's problem. Right. That's a highlight of LabVIEW. That's the reason most of the companies. If you see the previous slides which I was showing you, there are different companies that are using LabVIEW, but they were like of independent platform. They are like not related to each other. There are different domains. All the different domain people were able to use LabVIEW. All right. In this case, what I'll do is I'll quickly show a demo for you people how to use LabVIEW. All right. So that you people can understand how LabVIEW basically works. So what I'll do is I'm just simply launching LabVIEW window. So you can see that I'm launching LabVIEW. If you install LabVIEW, there are different versions of LabVIEW. You can use any. Okay, I'm using 19 version. The latest version is 2020. There is also beta version of 2021 released. The full version, which is the latest version available, is 2020 is the latest version. But I'm using one version later. I'm using 2019 version of LabVIEW. So here, this window, whatever you see, this window, as soon as you launch LabVIEW, you will see this window. This window is called as a Getting Started window. I repeat, this window is called as a Getting Started window. You have to launch any application related, programming from this window only. That's why this is called as a Getting Started window. Here in this window, I want to write a program. The LabVIEW program will be called as a VI. A LabVIEW program is called as a VI. VI stands for Virtual Instrument. All right. So I'll just take a file, new VI. New VI is the environment, workspace environment. Right? There are two windows always, a front panel and a block diagram. Right? There is always two windows, front panel and a block diagram. Getting it? Yes. So this is how you launch a LabVIEW window. Control T. Control T. T for tiling up side by side. So if I press Control T, what happens is half of my window will be, my screen will be occupied with my front panel, and half of my screen will be occupied with my block diagram. Front panel, I repeat, this is very important. Front panel is a place where your your user interface takes place. Block diagram is a place where your programming takes place. User interface, inputs and outputs. User interface is nothing but inputs and outputs. The front end. Front end will have only inputs and outputs. Block diagram, the back end usually. This is front panel and this is the back end of the front panel. This is where you'll be designing all your codes. Right now it is empty. I'm not done anything. Right? So I'll quickly show you how to launch it again. So once you launch LabVIEW window, you get this Getting Started window. Here, just say File, New VI. Or there is also a shortcut called as Control N. So Control N will launch a new VI. Getting it? Yes? Filing it side by side by using Control P. Clear? So if this is clear, I'll just quickly take you people for for section 2. So section 2, I'm just going to quickly tell you about the environment of the data type. Right? So how LabVIEW's environment and data type is being used, I'm going to tell you about. Before going into section number 2, I just want to know if you have any queries, please let me know. Do anyone have any queries? Any queries, anyone? I'll come back here so that if there's any queries, you people can let me know.
No, sir, not so far.
No, nothing, right? So great. So thank you. Thanks for the confirmation. You people can feel free to ask me any queries. So before that, going to the environment, I'll also show you a video. So to make you people understand like how industries use NA technology. Okay, this video which I'm showing you, it's a very old application. It was done in the year 2003, nearly 18 years before this application was done. This was done by a company called Soliton. Which they are like National Instruments partners who do a lot of projects related to NA technology, right? So I'll quickly tell you about this application. What this application is. This is a company called Hindustan. I hope you people have heard about Nadraj pencils, right? Nadraj pencil. So how the Nataraj pencil look like? It will look like red in color with black color stripes. This is how all the Nataraj pencil look like. How does a Nataraj color pencil look like? Have you ever used a Nataraj color pencil? It will be a pack of 12 colors. Usually the major colors, 12 colors will be there. For example, if I talk about a red color pencil will have a red skin. Brown pencil will have a brown skin. Green pencil will have a green skin. Pink pencil will have a pink skin. So that is easy for the kids to pick up the whichever color they really want to use. Hindustan is one such pencil company, a very old pencil company, famous in South India. I don't know about North. So it is being used in, they used to manufacture color pencils also. But one difference between them is all the color pencils have a same skin texture. What I mean by is it will be wooden texture. Think about a Nataraj color pencil without any paint on the top of it. It will have the wooden texture. All right. So what is the difference between a red color and pink color? Red will have a red color lead inside. Pink will have a pink color lead. Green will have a green color lead. All the skin texture will be same, right? So here we are supposed to segregate the pencils. What I mean by segregating the pencil is you have to just classify them based on colors, right? So this is like you can use humans to pick up the pencils because in a day they're like manufacturing thousands and thousands of pencils are being manufactured. And you have to segregate them so that it is easy for package department. Why package department? There are 12 colors, one from this, one from that, one from this, one from that. They'll make a packet. It's going to be easy. So color-wise, they're going to segregate. So the packing is going to be pretty easier, right? So they have automated it, completely automated it. Just see how it is done. You can see a lot of color pencils are there. They all have the same color texture, okay? Skin texture. There is no paint on them. Only the lead are of different colors. You can see they have an outlet at the bottom of this container so that all the pencils are automatically arranged on the conveyor belt. All right. So there is no particular sequence. No one knows on what sequence it comes. It's randomly arranged on the conveyor belt. You can see there's a camera. This is an NI camera, NI Smart Cam. This is a high-speed data acquisition frame grabber. Frame grabber is something but a camera which acquires a video processing. Okay. So you can see that the pencils will move in front of the camera lens. This is a camera lens. There's a pencils here. The pencils are placed in such a way that they expose the lead color to the camera. So the camera, what it's going to do is it's going to acquire all the information like first pencil is red, then it's green, then it's pink, then it's once again a red. So it calculates all the information of the pencils being arranged there. And here comes, whatever you see here, this is a solenoid, digital solenoid. I can give an example of, if you go to your puncture shop for your tire, where they put the air for the tire, right? Where they fill the air. There, what happens is they have a solenoid. That is also a solenoid. What they do is that is a spring type solenoid. They'll put it on the nozzle of your tire and they push it inside. So what happens is there is a spring which has a mechanical spring they have. It opens and high speed air will pass inside your tire. That fills up. This is also more similar to that, but this is not a spring type solenoid. This is a digital solenoid where when you give a digital high pulse, it opens and throws air. When you give low pulse, it will close and will just seize the air, right? So what happens is particular air gun or the air piston, this air piston will target only a red color pencil. You'll have multiple air guns so that every particular air gun will target one pencil. Just watch how it works. It targets only red pencil. It shoots a red color pencil. This pencil, because of the air force, what it happens is it flies and falls on another conveyor belt and get collected on another container. You can see there are multiple air guns. Can you see? This is the air piston number 1, targeting only red pencil. This one targets only green. This one targets only pink. It goes that way. Camera followed by multiple air guns. You can see all green pencils. And this is a LabVIEW application. I was talking about the front panel, right? This is how LabVIEW front panel look like. All right. There's a backend coding, backend block diagram is running behind, but that is not visible here. So you can see the front panel, how it is designed. So it is a user interface, graphical user interface. So you can see that this is a review screen, which has all the information of how many pencil passed, how many pencil failed, what is the pass configuration. You can set the configuration. You can log the data into the Excel sheets. Right? Can you see? It will log. Can you see export? This will log the data into the Excel sheet. Right? So this is how LabVIEW applications will basically work and look like. Right? So for you people, what I'll do is I'll quickly show a demonstration. What time we have a break, sir? Hello? What time I'm supposed to leave for a break or lunch? Vishwesh, sir? Can you hear me? Hello? Can you hear me? Am I audible? I think as per the schedule, it should be 12:30. I should break for lunch. I'm not sure. Can you just give me a response? Anyone? Am I audible? Vishwesh, sir?
Yes, sir.
What time can I just break? Should I break for lunch, sir?
Sir, at till 1 p.m. you can take.
I can go on till 1 p.m., right?
Yes, yes, sir.
Sure. Okay, sir. Fine. Thank you so much. Thank you. Thank you. So I'll quickly show a demonstration to you people of how LabVIEW basically works. All right. So now I'll just take a very simple example, the same addition of two numbers. That example I'll take you so that I'll just quickly tell you how to think from as a LabVIEW programmer. See, when you are a LabVIEW programmer, you have to think about designing the front panel and also the block diagram parallelly. All right. You have to just think about designing both parallelly. So now, when I talk about front panel, you should think about input and output. You should think about input and output, okay? When it comes to block diagram, you should think about the logics. This is very, very important. All right. So when it comes to front panel, you should think about what are the inputs I should have, what are the outputs should I have, and with those inputs and outputs on the block diagram, you should think what kind of logics I'm supposed to design. All right. So your arithmetic, logical, technical, looping, whatever you have, now all the logics will be available on the block diagram. Only on the inputs and outputs will be available on the front panel, so that your customer, when you submit this application as your customer will not be seeing your block diagram. It will be hidden. Only the front panel will be shared. Right. So you should have some inputs and output terminals, so that the person can use this. You getting it? Now, to do this addition of two numbers, I need, minimum two inputs, one output, and that is what you need it in the inputs and outputs. And coming back to your block diagram, logic-wise, I want to add two number, right? So I have to do a additional operation. So this is all I need. Overall, I need four things: two inputs, minimum, one output, and one operator. This is what I need, right? So just watch how I design in LabVIEW. LabVIEW basically use drag and drop application, right? LabVIEW basically use drag and drop application. You can just see whatever you want. Right click on front panel. If you right click on front panel, you get a palette called as controls palette. All right. So you get a palette called as controls palette. And if you right click on the block diagram, you get a palette which is called as a function palette. Don't forget that the palette available on the front panel is controls palette, and the palette available on the block diagram is a functions palette. So if you want to create any inputs and outputs, you have to open this palette, drag and drop the items from here. So if you want to do some logics like operation, like logical gates, right, or string applications, array applications, you have to open this, drag and drop the items from here. Getting it, right? So what I'm going to do is I'm going to quickly drag and drop two inputs and one output for numerical data, because addition of numbers is what I'm going to do, right? So when you right click and see here, they are like classified based on the data types. You can see numeric, you can see Boolean, you can see string, arrays, graphs. So they're all classified based on their data types. So what I'll do is I'll go to numeric. I want 2 inputs of numeric data type and 1 output of numeric data type, right? So you have a lot of graphical, devices here. There are graphical items here where you can make it to be a, input or output devices. Clear till this? One more thing I just added to this. In LabVIEW, your inputs are called as controls. Your inputs are called as controls and the outputs are called as indicators. We don't call it as inputs and outputs. We use the word inputs and outputs when it comes to hardware. So signal input, signal output, we call it as. So real-time signals are basically called as inputs and outputs. The LabVIEW simulated software, whatever we're using here, this is basically is a control and indicator. Right. So numeric input is nothing but numeric control. I click, drag and drop it here. I can give any name. I can name it as A or I can name it as input A, anything, my variable name. I can name it as X, I can name it as Y, whatever I wish, I can just name it as. And I need 2 inputs, right? So once again, I'll drag and drop it here. And I'm going to name it as input number B, right? So 2 controls are created. Numeric, I'll go for numeric indicator. I'll drag and drop on numeric indicator. This is nothing but output device, output terminal. I'm going to name it as output. So you have 2 inputs and 1 output. Only thing is you have to know where to drag and drop the items from. That is all you have to know. Clear? Yes. So that is all I've done it. So my inputs are created, my outputs are created. I told you when you design a front panel, think only about inputs and outputs. I was thinking about my inputs and outputs. I know I need 2 inputs of numeric data type and 1 output of numeric data type. Clear, paka, done. I've designed it. Now I'll come back to the block diagram. You'll see that once you finish your front panel, you'll see there are terminals on the block diagram related to the front panel. So you can see that input A has a terminal footmark on on your block diagram with the same name input A. Input B has a terminal on the block diagram with the same name input B. Output indicator has a terminal on the block diagram with the same name, right? You can see that. I'll just zoom in. I just zoomed in on the block diagram. You can see that there's an arrow mark which is facing outward for inputs, and for outputs it is facing inward. It is mentioning that the data are flowing outside. Inputs are source, outputs are destination, right? So you can see the source, it is sourcing data, so it is passing the data outside. The arrow mark is showing the data will flow from this terminal. Even here, the data will flow from this terminal. On the front panel, if you say a number 4 here and 5 here, that particular number will be flowing from here. This is why I told you LabVIEW is a graphical programming and it is a data flow model. Okay. And even here, the whatever logic you try to design in between, some logics you can design in between here, and that output will be updated here. And the output will come here. Getting it? Yes. So now what I'll do is I need to do addition of 2 numbers. I want to add these 2 data. Right click, numeric, add function. Inside numeric, I have all the operators related to addition or subtraction or whatever may be it. Handling the numbers, I have a lot of functions to do that. If I go to Boolean, you'll see the functions related to Boolean data type, logics, zeros and ones, right? So I'll go for addition, drag and drop, add. Clear. So now what I do is I'm supposed to wire them together. So just watch here. My cursor looks like a plus mark. If I touch this terminal, you can see if I touch this terminal, the terminal blinks and you can see that is a hotspot. This terminal, whatever you see here, the cursor is called as a hotspot or a wire spool. It's like a bunch of wires tied together. It looks like that. It's a graphical programming, right? It looks like that. Okay. So click and you can see wherever you go, there is a wire being following your cursor, right? So I want to connect it to this terminal. I'll click. Once again, click, move your cursor, click. From here, I'm supposed to pass it. It need not be always from here to here or here to here. It can be either way. Click, move your cursor, click. If you want to delete any of the wire, select it, click. Touch on it, delete. Touch on it, delete. Click on it, delete. Right? If you want to delete this, select it, delete. That is all. Like how we use it in your MS Paint, right? It's more similar to that. You draw items here. So draw wires, so that any data you pass, that will go to the operator. So let me say I'm going to pass, I'll just increase the size for you. I increase the size so that you people can see. You can just arrange them the way you want, right? Fine. I'm going to say I want to add a number of 38. It need not be, always whole number. It can be fractional number. Something like this, right? So what happens is as soon as I execute the program, right now it is not executing. I'll show you how to execute. This value of 38 will move to this terminal, and the value of 38 passes from here to the wire. So 38 passes to this terminal, and 7.923 that will pass to this terminal, and the added output of whatever may be the X value will come and display it here. You're understanding? Yes. So to execute this, on the front panel you can see there is a run button. On the top you can see a run button. If I click on this run button, you'll see the data flowed and the output was visible here. All right. So if I change any data, I'm once again supposed to click on run button, it will execute. I'll change the data, click here, it executes. It need not be positive numbers. It can be also negative numbers. Click here, it executes. Now I want a spontaneous output. As soon as I change, I want the output to be updating here. For that purpose, go for the next one, which is called as a run continuous. So when I click on run continuous, you can see the grids are vanished. It is still running. You can see that the symbol shows it is running. When I touch it also, it says it's running. So if I do any changes here, you can see there is a spontaneous update, right? Because it's continuously executing again and again, and is giving a spontaneous update. If I want to stop it, I click on this button, it stops. Clear? Yes. If I want to do some changes, now rather than addition, I want subtraction. What I am supposed to do is just watch. There are two ways to do it. There are two ways to do it. One thing is I select this, delete it. So you can see that the arrows are missing. I mean, the wires are like not connected. So there is a broken wire. And when there's a broken wire, you can see that code is having error. When the code is having error, you'll see that the run button is broken. It's graphically representing that you have a broken code. So when I click on this, it says that the wire has loosened, which means that the wires are not connected to anywhere. They loosely jump. They are like loosely, on the screen. So to remove your, loose wires, press Ctrl B. B for broken wires. All right. So you can remove the addition function, take and subtract, connect it together. That's it. This is going to work now. So when I run this program, it gives a subtracted version. It gives a difference between these two terminals. Very important. If you want input A minus input B, it is always top terminal minus the bottom terminal. If you want to jumble it, you have to remove the wire like this, connect it like this. So first terminal should be B, second terminal should be A. Now it will do B minus A. Right? Now it will do B minus A. If you want A minus B, it is always upper terminal minus the lower terminal. Upper terminal of subtract function, then the lower terminal of subtract function will give you A minus B. Right? Depends on what you connect where. Getting it? Yes, this is one type of doing, erasing or doing it. Or let me say if I want to replace this minus with the addition again, the simple method is right click on it, go to replace, numeric, addition. It will replace it with addition. So when I run it, it will do the addition programming. Simple. Just right click on the addition function, replace, numeric, anything which you want to replace it into. Getting it? Yes. So finishing this, if I want to save my application, how I save it is, I'll go to File, I'll say Save. All right. I'll just go to my desktop. All right. So I'll go to the folder. And here I'm going to say simple add. And you can see the extension of this is .vi. And you can see it is already saving it as .vi. So you don't want to bother much. So the extension is .vi, but anyway, it will take it by default. You don't have to give .vi. Don't give .vi because it is already saving it as .vi. Right? So you can see as soon as I save, this will turn into simple add.vi, front panel, simple add.vi, block diagram. Both get saved. They are both together a VI, they are saved. Getting it? So this is how you design a lab application. All right. So if I want a different thing, like let me say now I want to go for booleans. I want to do simple AND operation. AND operation. Let me say. So what I'll do is I'll take a push button. It can be anything you wish. Some switches. I'll drag and drop this here. I'm going to name it as this time I'll just name it as only A. You wish to give a name A. You can also copy paste. Select this. Control C, Control V. You can copy paste. I'm going to name it as B. 2 inputs individually. On, off. So they're interactive. You can see it's a graphically represented. This is a graphical programming language. You can see I'm just designing the UIs very quickly. And I want the output. I can go for a round LED, for example. I want a LED button or LED switch, something like that. I'm going to name it as output. It can be any name. I'm just giving output. All right. Yes. So same like that. You can see that 2 inputs, 1 output. But one difference is here you can see the terminals are green in color. Whereas in your numeric data type, you saw all the informations are orange in color. But when it comes to Boolean, it is green in color. Because it's a graphical programming language, you draw everything. When you talk about drawing, colors matters a lot. Coloring matters a lot. In LabVIEW, every data type has its own color. So by looking into the color itself, you can say what data type it is basically handling. This is a green color functions. This means that they are handling the booleans. You'll see that even the wires are green. I'll show you. So now I'm going to go for boolean. I wish I can use anything. What I'm going to do is I'm going to take an add operator or anything I wish. I'll drag and drop it here. Same like that from here to here. From here to here. All right, then from here to here. Right, so I'll run it continuously. You can see that this is low, the output is low. Low, high, because I'm doing AND, so AND operator, this is low. 1, 0, 0, 1 and 1, you can see it is high. Can you see? So with this, let me say I want to design a half adder circuit. So when I talk about half adder circuit, this has to be my carry, and I also need something for my sum. Copy paste, naming it as sum. Right? So once again, I go for Boolean XOR. So from one more terminal, I take it. You can see there is a wire branch. This is called as a wire branch. There is a wire branch which is going for this function and also this function, wire branch. So from here to here, wire branches. Okay. So this will be my sum and this will be my carry. A simple half adder circuit. You can design anything very quickly. So just watch here. 0, 0, sum 0, carry 0. 0, 1, sum 1, carry 0. 1, 0, sum 1, carry 0. 1 and 1, 1 here, sum 0, carry 1. Simple half adder circuit. Yes? You understanding how this works? And you can see even the wires are red, green in color. All right. The wires are all like green in color. I'll save this program also. So I'm going to name it as half adder. Right. With this, you can try to design anything, any different data types. You can drag and drop any items. You can quickly do any of the applications. Right? You understanding? If you want to quickly ask me, like how to do, palindrome. For example, palindrome. I'll just quickly show you the string data type also. So you can go for string. I can go for string control, string in data. What is string control? String in input, string output. Okay. So I'll drag and drop this. I'm going to name it as string input, where I can type the data inside. Right? I can just type whatever I want. This is string data type. Fine. So I want to find whether it is, I want an indicator. I'll take a round indicator. So this is going to be my output. So I'm going to show us the result. Right?
So if the input which I type, if it is a palindrome, it has to internally calculate if this is a palindrome or not. If it is a palindrome, it should be high. If it is not a palindrome, it should be low. This is what I want to do. You understanding? I'm just quickly going for a next application. Okay, I'm just showing you all different data types very quickly. Afternoon, coming back from the lunch, we'll go slowly. I'll take much more time. I'll go in detail with every data types and show you how to do that. All right, fine. Just watch, yeah. Just watch. So this string data type input will come here. Whatever I type here, like last time you saw, right? I typed numbers, right? 22, 23, 73, whatever I type, it was coming from this terminal, right? Something like that. If I type hello, that character will come from here. So right click, string palette, there are a lot of functions related to string here, right? So I'm supposed to find something, how this basically works. So I'll tell you what is a palindrome. Palindrome is like, for example, if I type a name called I, right? If I type a name called I, the reverse of I will be still I. Maybe since it's a capital, I'm writing it in reverse, so it is a I, right? So for example, if I say madam, and the reverse will be once again a madam. But if I say madame in French, the reverse of this will be something else. So here you can see that this is a palindrome, this is a palindrome, this is not a palindrome, reverse is not the same, then it is not a palindrome. So it has to be showing here. If I type, for example, any other palindrome, which, for example, civic. Civic is a palindrome. Okay, civics we call it civic. So civic is a palindrome. So when I reverse it, it is going to be once again civic. It should show high here. If I say civics, S is added, the reverse is not the same. So this should be off. This is what I wanted to design. All right. So to do this, first of all, I have to find the reverse of this input. So to do that, I'll go to string palette. I'm coming to the logics. Okay. So I go to addition string function. There I have something called reverse string. The only problem is, just tell you, as a beginner, you people will not know where to find what. I have been using this for nearly 10 years. This tool I have used for 10 years now, currently. Okay, so I know what the function is where. Whichever function I want to use, I know where to pick it from. You will also get it. See, it's like when you install an app in your phone, very first time, you don't know where to find what, correct? So you have to just simply roam around, understand the environment, just try each and every application. For example, let me say you would have booked the Ola cab, right? The first time, maybe you would have finding it difficult to book, how to book, what is the procedure, what is the payment mode, should it be a cash? Let me say I don't have a cash, I want to use a UPI, how to change it. That's like a lot of confusing things you have. But first time you book it, second time you book it, 5, 6 times you book it. After that, it becomes very common and easy for you. That is how Lab is all about. First time, maybe it looks very complex. You don't know where to find the items. It is simple only, but you don't know where to find the items, right? Then once you start using it regularly, you'll be understanding where to find what, right? So I'll go to addition string function, reverse string. So what is it going to do is, for given input, this will give the reversed data. So now I have to do this reverse data and the input data are same or not, whether they are equal or not, I want to see. So right click, I have comparison, right? I have comparison to do that. I'll check whether they are equal. I'll drag and drop this here, reverse and the actual data. So you can see that there's a branch. So this will pass the data here and also here, and this will pass the data here. This is what is called as a data flow model. You can see the data are flowing from here to here and also here to here. This will flow here. This will compare the reverse data and the actual data, is the same or not. And the output, it will write it here. Simple, right? If they are same, it will give you true. If they are not same, it will give you false. All right, just watch here. Can you see civics is not a palindrome? I'm going to type this madam. You can see that it says that the given input is a palindrome data. Getting it? Yes. So if I say hello, it says it is not a palindrome. If I say once again I, you know I, right? I is a palindrome. But now you can see it says it is not a palindrome. Why? If I say EYE, with small character, it says it is palindrome. When I say EYE, it says it is not a palindrome, which means that this is case sensitive. This application is case sensitive. Now let me say you want to make your application into a case insensitive. So what I'll do is here in between, I'll remove this wire. I wanted to do a logic. So before doing any logic, in the very first, what I'll do is I'll make it case insensitive and do all the application. So what I'll do is I'll go to string. There is option to convert all the data to upper character, all the data to lower character. I'll convert it into lower character. If anything is fine, both of them are fine. So when I pass it like this, internally, all the characters will be converted into lower case, making it more case insensitive. And then I'll do the application. Now you'll see that I run continuously. If I say EYE, it says it's a palindrome. EYES, it's not a palindrome. If I say capital EYE, it says it is a palindrome. If I say once again add a plural to it, it says it's not a palindrome. You understand? It's all about how you drag and drop the item, right? So from here, the data move here. So the capital EYES moves here and will convert it. So the output from here, it's going to be all small letter EYES. And then it flows here to check the comparison. From here through this, it will reverse it. So it will turn into SEYE, the reverse. And then it will compare, it will say it is not same. So it will throw a false here, right? So if this was like this, same like that, it will convert it into a smaller version of EYE here. Here, the reverse also is going to be EYE. The same data EYE and EYE passes here. Here also it's going to be EYE. So it will compare and the output is going to be true. Because this terminal is also having the same value. This terminal is also having the same value. It will give you a true. You understanding how this works? Any doubt in this? I'll save this as a...
No, sir. No, sir.
Thank you. I'm saving it as a simple palindrome. All right. Clear? Yes. So if you have no queries related to this, I'll quickly take you through some slides. So it will be a refreshingly a recap of what we did. So you can have the front end, the same replication of the front end of any instruments, desktop instrument in LabVIEW. This is why LabVIEW is considered as a virtual instrument. You can see this is a front panel of LabVIEW where they have used graphs, knobs, some of the drop-down list options, run button, a lot of buttons they have used with some pictures into it. And you can see there is a Boolean to choose on and off, right? So this is how you can design your front panel. All right. And backend can be the program, how basically a desktop works. What I was showing was a simple examples. And complicated examples will be something looking like this. You can also try to design any software. If you know how this basically works, if you know how to program it, you can design any of the front panel objects, a virtual instrument object, right? So coming back here, so usually your LabVIEW has 3 components. Let us not talk about the third component right now. We'll come back to it later. So for time being, just keep it like something like we have 2 components. One is a front panel and one more is a block diagram. Front panel is a place where your inputs and outputs takes place. Block diagram is a place where your actual application takes place, right? So inputs and outputs will be dragged and dropped on your front panel. Your logical items will be dragged and dropped on your block diagram, right? So what is the palette available on the front panel? When you right click on front panel, the palette name is controls palette. When you right click on the block diagram, the palette name is functions palette. Controls palette and functions palette. All right. So this is how these 2 windows are made up of, and the extension of LabVIEW code is .vi. .vi is extension. I'm coming from a company called as VI Solutions, right? It's more similar to that virtual instrument solution. All right. So in the front panel, you can drag and drop any of the items. Can you see? You can drag and drop any of these kind of items. And after the break, I'll just show you something further. You can have numeric, it can have strings, it can be having booleans, like we saw this, right? We saw these booleans also, right? It can be graphs, it can be knob, it can be meters, gauges, thermometers, it can be anything. Even 3D applications. That's how we design, biomedical 3D images also we try to design. So this is how controls and indicators looks like. Controls are nothing but inputs, indicators are nothing but outputs. In LabVIEW, we call inputs as controls and indicators as output, right? So coming back to block diagram. So block diagram is a place where your source application takes place, right? So you can drag and drop the items and you can have to wire them together. All right, you have to drag and drop items and you have to wire them together. But one thing you have to remember, on your block diagram, the controls will have the terminals on the right hand side facing outward. what I mean is, I'll come back. I'll show you what I actually mean. You can see here. Here, string input is a new, it's a string input, whereas the result is a Boolean output, right? Irrespective of whatever data type it is, if it is input device or input item, you can see that it is having an arrow mark facing outward, saying that this is a sourcing material. It is sourcing the input. And if it is an indicator, it will have the connection terminal on the left hand side facing inward, because it is displaying something. It is getting the data and showing you something. All right, so input item and output item, the arrow marks define whether it is passing the data, no, sending or receiving it. Getting it? Yes. So then there are different types of data types we have, and they have their own colors. I'm going to quickly tell you about the colors. This is very important. I'll just first talk about the first 4 colors, what we are going to use today. Today we'll be using all these 4 colors. Maybe in this last one is the error type, which we'll talk about it later, right? Right now I'm not taking it, but in case, yeah, we'll work on that also, no issues. So your floating point, your numbers can be classified into 2 types. One is an integer and one is a floating point. All right. So floating point can take a fractional data. Integers usually take a whole number. All right. So your integers are blue in color. Integers are blue in color. Your floating point is orange in color. Your booleans, we saw the boolean wires were like green in color, and strings were pink in color. So these are the basic 4 data types we'll be working today. I repeat, we have 4 colors, 2 for numerics. For numbers, you have integers and you have floating points. Your integers are blue in color. Your floating points are orange in color. Your booleans are green in color, and your string is pink in color. And then comes your error. We'll talk about it later, because you can also inject error, and you can also test the errors, and you can also handle the errors. So error wires will be gold and yellow in color, right? Not just yellow, it is gold and yellow in color. Getting it? Yes. And your wiring tool in LabVIEW, on the block diagram, to wire terminals together, from functions to terminals, from addition program also we saw that how to do it. So you have a cursor called as hotspot. Okay, this is a wiring tool. If you touch the terminals, it will turn into a hotspot. You can see how it looks like. It looks like, there is a bunch of wires tied together, right? Bunch of wires tied together. It's a wiring tool. That's why it is having a wiring symbol also. It's a graphical program, right? That's how it looks like, right? Excuse me. And very importantly, in graphical programming, especially in LabVIEW, you can see the thickness of the wires will vary according to the data type you use. So if you're using a scalar data type, it will be normally thin line wires. If you're using 1D array, what I mean by 1D array, it's like, it comprises multiple data inside it, right? So it will be little thicker. Compared to the scalar, it looks thicker. If you're using 2D array, if you're passing a 2D wire, then you can see it will be double wires. Can you see it will be even more thicker, double wires? You're understanding? So the thickness of the wire also matters, right? Don't forget about the thickness, and don't forget about the colors. This is very, very important. So your floating points are orange, and scalar will be thin. Your 1D will be thicker or bold, and then your 2D will be having double lines. And coming to integer also same, integer, but it handles all blue color data. Your booleans will be green in color, your strings will be pink in color, and your errors will be gold and yellow in color. So hope you people are fine with this. So any queries, anyone? So coming back from lunch, we'll be start trying to jump into some further applications which will be more complex as per the schedule. Also we'll be jumping into section 3, where we'll be trying to do some application which is like decision making algorithms, iterative algorithms, continuously repeating it. So based on the iteration, right, if you want to change the executions, all these things you'll see. Okay. And also on the front panel, we'll also try to use some more items like gauge or meters or other graphically represented items. We'll just try to see. Clear? Yes. And if possible, after lunch, if you have any possibility to install LabVIEW and come with hands-on, I'll be very happy. So I'll be able to give you some hands-on, make you people do this. So when you do it, you get more doubts, clarifications, everything will be there. Getting it? Yes. So when you do it, you come up with a lot of problems. You will just find a lot of issues. Clear? Yes.
Yes, sir. Yes, sir.
Any queries we have, I'll just handle it if there's any. Okay, there's no queries. There's only feedback form to fill it up. Yeah, you people can fill up the feedback forms. Fine. Right? So we can just wind up for break. We'll just have lunch and come back. What time we'll gather back?
Sir, is it okay if we start at 2 p.m.? Okay, 1 hour.
Yeah, I'm fine. I'm fine with 2 to 2:15 we'll start, okay?
Okay, sir. Yes, sir.
Around 2 to 2:15 we can start. Thank you so much, everyone. I had a very good first session. So going further, we'll also have some hands-on if possible. And thank you all so much. Right?
Thank you, sir.
Thank you, sir.
Yeah, you're welcome.
All the participants are requested to join at 2:15. Okay, so I will be notifying it over the WhatsApp group. Please fill the feedback form, and thank you one and all.